I want to show how to solve some linear equations that involve absolute value. And so here I have three examples I want to go over. And if you remember, when we do absolute value, for example, if I think about what kind of absolute value has 6, I know that to be two answers. I know that x equals 6 has absolute value 6. And also that I know that if absolute value of negative 6 is 6 as well. Okay, so the negative version and the positive version have the same distance from 0, and this, remember, distance from 0 is a good intuitive way to think about absolute value. So how does that apply to these equations? Well, here when I say absolute value of 3x minus 2, I'm saying that this expression is unit 5 away from 0. And that could be unit 5 in the positive way or in the negative way. So I end up with two equations. I end up with 3x minus 2 equals 5, or 3x minus 2 equals negative 5. Okay, so I end up on the first one, I'm going to say 3x equals, I have to add 2 to both sides. Okay, so I get 3x equals 7, or x equals 7/3. There's my first one. Now on the other side, I'm going to add a 2, and I have negative 5 plus 2, which is negative 3. So then x equals negative 3 over 3, which is negative 1. Okay, so now as a solution set, and here solution sets are a great way to represent this because we have more than one solution. My solution set is 7/3 and negative 1. Alright, so for the second one, I have absolute value of negative 8x plus 2 equals 14. Okay, so I want to drop the absolute value. And when I do that, that means I have two situations to consider. One's that negative 8x plus 2 is 14. The other side is negative 8x plus 2 equals negative 14. Okay, so I solve these two equations. The first one here, I'm going to subtract 2, so I end up with negative 8x equals 14 minus 2, which is 12. So x equals negative 12/8, which we can simplify. Let's say I can divide by 4 and end up with negative 3 over 2. Okay, now on the right equation, I'm going to subtract negative 2 and end up with negative 8x equals negative 16, or x equals a positive 2. So then as my solution set, I have negative 3/2 and 2. And you can verify if you want. You can plug in these values into my absolute value equation, and you should get an absolute value of 14. Okay, now in part C, this one's a little bit more involved, right? We have two absolute values going on. Okay, but it's not really that big of a deal. So what it's saying is that this guy, his distance from 0 is the same as this distance from 0. So this actually generates four situations. It can give you 2 minus x equals 2 plus x. It can give you 2 minus x equals negative times 2 plus x. It could give you the situation where negative 2 minus x equals 2 plus x, and then it can lastly give you the situation where negative 2 minus x equals a negative 2 plus x. But if you think about it for a little bit, this equation and this equation are the same because you just multiplied 1 by a negative 1, so we don't really need to worry about that one. And actually, this one and the first one are the same as well because I can multiply both sides by negative 1, and so I don't have to worry about that situation either. So these are the only two situations I have to worry about. Okay, so first I solve the one on the left, and this time I'm going to go ahead and I'm going to add the x over to this side. So I add x's, I get 2x, and I subtract my 2's, so I have 2 minus 2 is 0. So I end up with x equals 0 from the first equation. Okay, in the second equation, I have to distribute the negative, so I end up with 2 minus x equals negative 2 minus x. And this is going to be a problem because if you notice, if I add the x over, I end up with 0 x's, and when I add the negative 2 over, I end up with a positive 4, which is not going to happen, right? So here I have no solution because I had a contradiction. So in this example, my solution set then is just 0. Okay, that's my only solution. Alright, now one last thing you might encounter, so I'll just quickly jot it down an example. You might end up with something like this. The absolute value of x minus 1 equals negative 36. Okay, now if you try to do the work, you're going to end up with some contradiction statements, and you can do that through the same methods that we've done earlier. But notice that the reason that you're going to get a contradiction is because how can you have an absolute value that ends up being a negative 36? So if you're clever and you see that ahead of time, you know automatically there is no solution to this equation. You cannot have an absolute value that ends up being a negative value. Okay, I hope this makes sense. I try to show you everything you may encounter when you're dealing with absolute value equations, and it's very useful. You see these type of things show up all over mathematics. Please let me know if you have questions. I'd be glad to help you, and thank you for watching.